All right. It is about 13 after 8. So we'll go ahead and do a little brief presentation here on quantum computing. What I'd like for you to do, go do some web searches, look for quantum computing, because what you're going to find is that no one has a quantum computer. IBM is one of the farthest along in developing it, and recently they actually made one quantum bit processor. In other words, they had one thing, one machine. In other words, had 4 gates in, and they could actually differentiate between different types of error and logic errors as well. Those were major steps for them. So what does quantum computing do? It depends on literally quantum physical effects from the hardware, which can be affected by temperature or stray electronic fields, abnormal production methods, errors in the hardware, anything. But here's what you really have. You have this device that has 4 different inputs. Each one of those inputs can have 2 different states. In other words, input A, or Q1, could have a 1 or a 0. Q2, 1 or a 0. Q3, 1 or a 0. Q4, 1 or a 0. So what you already have, an ordinary computer or CPU processor has 1 gate, and it can be a 1 or a 0 to compare these different things. So the quantum computer is already 4 times as fast because it has 4 instead of just 1. Well, here's the other thing about this quantum computer. Because it's so much faster, because it's able to process that width of information, it literally is much, much faster. For example, about 20 times faster, they expect, about 20 times faster, maybe more, than the normal silicon computing that we have now. So if something's 20 times faster, that means it has 20 times more processing power. So think about that. If you took your cell phone and put a quantum computing chip in it, it would suddenly have the capability 20 times what it has now. And that closely approximates what you might have in a high-end laptop or a high-end desktop in your cell phone. So imagine what would happen in a high-end desktop or a high-end laptop, 20 times faster. And there's some really threats with that. And here's some of those threats. Think about encryption and security algorithms. One of the reasons that they last as long as they do, and they last only until someone decides to spend enough time trying to break the algorithm, some days, a week, something like that, if they're really concentrating, reduce that by 1/20th. Now we get really interesting. Something that would normally take a full day to break, you'll break in an hour. Wow. Okay. And as a result of that threat, a lot of nations are performing research on quantum computing because they want that capability. Now, that's just the national effort, but let's think about the commercial effort. Yes, 20 times more power in your cell phone, right? And the first company that has that develops and sells that, look at the advantage that they will have over those that are still putzing along at 1/20th the capability. So we have a couple opportunities here. We'll have a much better hardware, and the better hardware means an opportunity for better software. And then a combination of software and hardware means a better opportunity for MIS. And so quantum computing, which should be, at least predictions are, effectively in use within the next 15 to 20 years, means everything will be obsolete that we have. 15 years, maybe 20 at the most. And you will be here to see that. Isn't that exciting? Go ahead, do a little bit of research and look at some quantum computing. I talked to an executive a couple days ago, and he brought it up. He said, quantum computing will really affect cell phones. It will really affect wireless. It will really affect anything that uses computing. Okay? So you guys have fun and good luck. Enjoy your last week.